Hello guys, welcome to the day 2 of the Flutter masterclass. So in the day 1, which had went yesterday, we had actually had a brief description about Flutter and the programming language Dart, and then we have just gone on to the editor and just worked on sample programming, like the basic procedural programming you can say. But this is day 2, so we're gonna talk about the object-oriented programming in Dart. So Dart, unless like similar to other programming languages, is also an object-oriented programming language. So it contains the topics of classes and objects, exception handling, generic types, etc., inheritance too. And yeah, you can we are going to discuss about all these 4 topics. So yeah, let's cover one of them, one on each of them. Okay, first of all, let's go to the classes and objects. So yeah, as we have used yesterday, void main is actually, or the main function is actually something that is actually going to fire up whenever you execute an application. So yeah, so in order to create a class, we use a class keyword, and after that we give the entity. Before creating a class, I would like to explain you what classes are and why we require this kind of concept. So if we talk about the data types which we have read yesterday, the integer, string, boolean, etc., so we can actually save the data, but there are complex situations where you can have a nested kind of a data or a multiple entity kind of a data. For example, if there is a student, the student will be having his name, his marks, his section, his roll number, and his standard, his year of graduation, etc. So there are actually a lot of entities that would actually need to be covered whenever we are that need to be covered, and whenever you're gonna code it in a programming language, or going to implement those concepts in a programming language, then we need to have an optimal way to represent that, and that is actually classes, because classes we can have those entities. For example, if you created a class called student, and that student actually have entities like name, so which is actually going to be a string, and a roll number you can say, and then we can also have the section, and there are, we can actually add more parameters. We can also add marks. So yeah, I hope that is enough. So we had just created a class called student, and it can actually handle all these entities. So similarly, in a class we are having a number of students, and in a similar way we can create multiple objects, and the multiple objects of each of these objects can be represented as a student, and each object of that actually have the entities of name, roll number, section, etc. So in order to do that, we can actually head over to the main function, and we can create an object just like student, and giving a object name. For example, student1 is equals to student. Perfect, right? So yeah, that's how you can actually create a student. They're spelling it wrong. Perfect. So yeah, that's how we can create an object, and that object we can actually set the data as stu1.name is equals to Similarly, you can give stu1 dot roll number as 23 maybe. stu1 dot section is equals to then standard stu1 dot marks which is an integer, so let's give it 82 marks out of 100. and that's how you can actually add the information of a particular student like this. And we can actually print the same by calling stu1 dot name. It would actually print the name of the student. Now if I execute this, then it would actually print out the name. And similarly, we can actually print out the student roll number, student section, followed by student marks. And then if I execute, I can actually print out all the information of the student. There we go. So yeah, that was pretty cool. But there is a concept called these are actually all the entities, and we have these variables inside a class, and then we can also use functions in the classes. So if you want to actually use functions in the class, those are called the methods. So how to create a method? So we can create methods by having a return type void. This is actually a function, and the functions are actually called are called methods inside a class. So I can actually add the data just like we did over here, like this. You can add the data like this, but we can do the same by creating a function or by creating a method for that. And then I said add data, and I can actually add like this, and we need to actually pass the object reference so that it could understand in what kind of an object it actually need to pass the data. And then we can actually call that method by passing like stu1 dot add data and stu1. So this is the object, so we can say this is the student name, and we are telling to add the data, this data, to the student 1, and it was adding it was taking that data, the student reference, or you can say the student object reference, and that thing is actually assigning all information to that student. And if I execute the same, it would actually get the similar output, but it was actually handled by the method classes, by the methods. And similarly, you can also print the data by passing what kind of a student details you want to print, and you can actually print it similarly. Instead, you need to just say st1 show data, and we need to pass the same, and it could actually print the data. And if I run it, it could actually get the similar output, but again, this thing is actually working based on the methods. So that's how you can create classes and objects. And there is also one more parameter called constructor, which represents whenever instead of adding the data in this way, it can actually assign the data automatically whenever the object of that class is actually initialized. So similar concept. This is how actually classes and objects work in the Dart programming language. Alright, so we are done with the classes and objects, and now we're going to talk about inheritance. So again, I'm going to create a new Dart pad, and I would like to talk about inheritance. So I'm going to have the same old code that we have just written out, and I'm going to implement the concept of inheritance in this. So what I'm going to do is instead of showing the data over here, I'm going to creating a new class which should inherit the characteristics of the previous class. So I'm going to create a new class which is called child class, I can say, and inheriting that with the first class is done with the help of a keyword called extends, and I'm actually telling that to extend the characteristics with the. So what I can do is I can actually in the child class I would like to show the data, and then what I would like to do is I would like to use the child class to actually add the data from the object of the child class. So I have just created the object for this, but what I would like to do is I would also like to create an object for the child class. well, it is actually recommended to use capital C's for class notations. So let's do that. So yeah, so I have just created the object for the child class, and then I can say child dot, and you can see add data over here, but this add data is actually for the class 1, which is actually the parent class. As it was extending, we can actually expect to see the characters which are called the inherited characteristics, and I can pass the student 1 parameter again, so to actually add the data. So I doesn't need to do like this, which is in the bottom, so I had just removed that, and it would actually show data, but it cannot because we have just changed that block of code or the function that could actually show the data in the child class. So now if I execute it, you can actually see the same output, but now we are actually inheriting the characteristics in another class, and we are working with the inherited class, and we are getting the data with an inherited class. So we can actually say we can even extend the child class to another sub-child class, and that is actually called multi-level inheritance. And we can actually inherit this class again under another new class, so that that is actually called multi-value inheritance. So there are actually different kinds of inheritances, but I would like to make this pretty basic so that you guys are able to understand easily. So I just this is actually pretty basic. So yeah, that's what inheritance actually is: inheriting the characteristics from one class to another class. Perfect, and we are done with inheritance. Now I'm going to talk about generics. Generics are one of the most interesting topics in actually any programming language. So if you got a main function, and I can say we got a list. Imagine if you got a list having data, and you're actually having some names of the persons. So now we got the names of the persons, and now each of the element in that list is actually a string, and now I can print that, and if I execute this, it will just log out the list having all those names. So generic, what does it actually mean is to go precise with what we're actually trying to pass inside the list. So as I'm passing inside that list is a string, so I need to I can make it much more generous so that it could actually understand that I'm passing a list. I'm passing a string inside that list. So each and every entity in that list is expected to be a string. Instead, if I pass an integer like 86, then it would to throw an error. You can see on the log, and if you hover over there, it was saying that the element is an integer, but it is actually expecting a string, because we made this list much more generous so that it need to understand that. And similarly, as we have created this class, which is actually a student class, I can actually make that class to use in a generic manner over this list. So I can actually remove the string, and I can actually use student over there, so that it could actually we can actually make the list to actually take the data inside in the form of student. So it could actually take the list of elements of student object. So if I remove all the content, which is actually string inside that, so if I remove pretty much everything from that, then I can pass the student references. So you can see the object references of the student. So I can say student, and then you can actually add name, marks. You can see the entities which are available here, etc. So you can actually pass the objects, student objects over here, instead of passing the string or subtype. So this is what makes this is what is the use of generics. So whenever you actually wanted to pass a kind of data or a structured data, then you can actually pass that data with the inside a list or anywhere. You can use iterators, even though you can use queues, you can use stacks for that, and you can make it much more generous, even though you can use the objects or the class types for the same. So yeah, now let's talk about exception handling. So yeah, in every programming language we actually create a main function. So yeah, what are exceptions before doing that? So exceptions are actually the stuff where we can actually find the errors, and before actually executing that error piece of code, we can actually catch that error, and we can actually throw the error that you cannot perform these operations, which would actually make it much less buggier for most of the application. And finding these kind of errors is necessary because for a successful application, it doesn't need to be buggy. It need to be smooth enough, faster, and it need to be work stable. So in order to find these kind of bugs, we need to use exception handling. So in order to do that, let's go with a sample code to understand that again. So imagine I have integer value 10, and then I have an integer value b, which is 0, and then I have an integer value c. And what I'm actually trying to do now is I am actually trying to divide a with b, and then I'm going to actually make it rounded. The symbol actually makes the round value because the float value will be converted to an integer, and that will be saved to c, and we can actually print that value of c over here. And if I now execute that, it would actually say unsupported operation, result is infinity. So in these cases, you can actually use try catch block. So before performing this operation, which is actually a division operation, we can actually pass that code inside a try catch block, and whenever it actually found that that operation doesn't actually work as expected, then it could actually throw error. Cannot perform that operation. Now if I execute this, okay, I forgot the semicolon over here. And also you can actually print your exception. See, you cannot perform the operation, so it haven't performed the error. Instead, we actually caught the error, and then we just logged out that this is the error that you actually have in this operation. So the thing is, we haven't seen the error, so that's what actually makes applications reliable and stable. So you can actually see what kind of error it is by printing the e. This is actually the parameter that the try catch block over here will catch the kind of error, and it will be passed that will be passed inside this variable. And you can see that what kind of an exception it was. And in more precise manner, this code doesn't work as expected in the dartpad.dev. Instead, if you actually install on your machine the dart I'm really sorry for this tabs. Okay, if you have actually installed dart in your computer, then try to execute that in your command line, then you could actually understand that. So you can see the kind of exception, which is print e, is integer division by 0 exception, and then you can see the log that you actually said that you cannot perform this operation, and this is actually c because it is null. So yeah, I hope you guys understand the exception handling. Thank you for you guys watching, and I hope you guys liked the video. So thank you. Peace.